Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So, my name is Neeraj Kedia, and I've been working in this IT industry for more than 13 years now. So, let's start our discussion on Python for data science. So the main agenda for today's session, we are going to discuss on the need of data science, what exactly data science is. Then we are going to discuss on how Python is used for data science, how we can manipulate data in Python, how we can implement machine learning using Python, and then we are going to work on hands-on. So first of all, Python for data science is a must-learn skill for professionals in data analytics domain. So now with the growth of IT industry, it is becoming a prerequisite for anyone to get into who are looking to get into data science. So they have to know about Python. And Python is the most preferred language because of multiple reasons. One of the main reasons being it has multiple inbuilt libraries that are specifically used for the purpose of data manipulation and analysis. So if we talk about data science first, for example, if we talk about the need of data science, then data science is, in simple layman terms, is used for increasing the accuracy of the prediction, right? So using data science, we can increase the chances of being correct on the possibility or different possibilities for different business problems. For example, let's say Amazon needs to predict, okay, what is the user demand going to be in next 6 months? So it can either base its operations on the hypothesis that is given by experts, or it can base its entire expenses, its entire marketing based on the actual analysis, which will have a more amount of accuracy. That means it is going to have a higher chance of being true as compared to the hypothesis even coming from the experts. So if you talk about the earlier scenario, then earlier majority of the data used to be in the structured format. That means if the majority of the data used to be in either in tables, rows and columns, where we could have easily sorted the data and we could have worked on it. But since the introduction of 4G back in 2016, there has been a simple explosion in the amount of unstructured data that's available out there. Now, when we talk about unstructured and semi-structured data, so we refer to images, audio clips, video files. We have multiple sensors data, XML data coming in. So these all are the unstructured raw data set, which cannot be processed by using the structured data analysis method. So that's why, and these are all complex as well. That's why the normal analysis is not going to be possible on these highly unstructured data set. Same way we have data warehouse. So earlier we could, since the data was structured, so we could store the data coming in from different resources into a centralized data warehouse. For example, we could have data coming in from the CRM, from the ERP tools, from the databases. So again, these all were structured. So we could have used data warehouse for that. But if we are referencing to the unstructured data, or we can say unfiltered data set, that we can make use of data lake, or we can make use of the Hadoop infrastructure, as in Hadoop distributed file system that we commonly know as HDFS. And then earlier for the structured data set, we could have used the traditional BI tools, whereas now for the analysis, we have to work with multiple data science algorithms. And earlier, since we were working with BI, so a simple report would have been generated from the given data set. But now, since we are working with prediction modeling, so it has to have all the integration for multiple tools and libraries integrated as a part of the calculation, so that we can also use it for the machine learning. And then the machine learning is going to implement the same thing to automate the process of analysis. So if we talk about data science, then data science has been a promising career path for skilled professionals. So the truest essence of data science lies in the problem solving capabilities to provide insights and solutions driven by data. So there's a lot of misconception when it comes to data science. So data science life cycle is one effective way to get a clear perspective of what data science actually is. So basically, if we talk about data science, then first of all, it involves discovery, which involves problem statement, understanding what exactly the problem statement is. Then it involves data preparation. For example, if we may have to acquire data from multiple sources, we have to pinpoint, okay, how exactly data is going to be there. Then we have to work on data processing as well. That means we know that majority of the data, they all are highly unstructured. They are in raw format. So we do need to process data before we can work on it to remove all the anomalies and different or we can say if we have multiple garbage value and anomalies, then those can be removed. And then we have model planning. So here we can choose what kind of model we want to create. Basically, when we are defining models, we simply means the models that we can create for the machine learning part, so that we can use this data, we can use this model for training an AI algorithm based on the input that we may have selected. And then we have and then we can build a model out of it. And then we have operationalize. That means we can execute the entire statement. That means we can deploy the entire algorithm by using the correct platform, and then we can slowly and gradually, first of all, we can test how effective the algorithm is, and then we can start working on the actual deployment. So data scientist provides a simple one-stop solution at all for all the problems here. And that's why we are seeing again, data science is what? Data science is basically free, it is flexible, and it is open to multiple platforms. That means it is not platform specific as well. And it simply is used to reduce the entire time into half with simple and easy to read syntax as well, because it is mostly based on Python, and we know that Python has the least amount of grammar as compared to any other language. So if we talk about the programming languages, then we can use R. R is mostly used for statistical analysis. Python is the most widely used and most famous language for data science. Then we have for SQL, we can use SAS, we can use MATLAB, and we can use the evergreen Java. So if you talk about Python for data science, so Python, as you know, is the easiest language to start with, having the least amount of grammar, and multiple inbuilt libraries are available in Python that are used, they are built specifically for the scientific and the graphical visualization of different data sets. It is free and simple to use. It is platform independent. That means we can create in one and then we can deploy in another. There is no platform dependency. It is a high level and interpreted languages, so we don't need to have a focused compiler that like we have in Java. So in Java, we have to first of all create a build, and then only we can execute that build. The same setup is not available for Python, and is useful for in data manipulation, analysis, and visualization as well. And for completing these tasks, it has powerful libraries that we can make use of. So these libraries for machine learning application and other scientific computation can be easily applied. So if we talk about data manipulation, so we can perform the entire ETL activities. We can perform multiple ETL activities. ETL as in we can extract, we can transform, and then we can load the data as per the requirement. For example, if we have a CSV file, so also or we have a database, so first of all we have to extract data from it, then we have to transform the data from one format to the other. If the format is not specified, for example, we have the Excel sheet that we may need to convert to CSV for using it with the libraries, and the libraries used are NumPy and Pandas. So NumPy, as you know, it's basically a Python package which stands for numerical Python. So if we talk about numerical Python, that means we are going to use it for scientific calculations, for any of the calculation, and it is one of the core library available in Python for data science. And it can be used as multi-dimensional container for generic data where we can perform various NumPy operations and functions. And then we have Pandas. So Pandas is an important library in Python for data science. It is used for data manipulation and analysis. It is well suited for different data such as tabular, ordered, unordered, and we have the time series, we have matrix data. So these all are a part of Pandas. So to install NumPy, we can now if we are using Anaconda package, then we can use conda install NumPy. Or if we are using the Python CLI itself, we can simply work on import NumPy. So this is going to install these packages based on the configuration that we have done. So let's say if you want to work on any of the libraries, if we want to work with, we can either choose a CLI. For example, if you want to get started, let me showcase you how we can work on Python. So if you want to work on Python, then first of all, we can download Python by going to this link here, python.org. And here we can choose which version of Python we want to get started with. Now we can choose which version of Python we want to install from 3.9, from 2.7 till 3.9. And we can also use, once we install it, we can open up the Python CLI to get started. So you can simply use the Python CLI to get started. Or if you want, we can make use of a complete IDE as well. Now, when we refer IDE, we simply mean an integrated development environment. For example, we have PyCharm. We can make use of PyCharm to get started on the development. So in case you want to work on any of the IDE, then we can install PyCharm as well. So PyCharm is basically one of the popular IDEs available for Python. So when we say IDE, it refers to integrated development environment. So we can click on download. It's more like a GUI based. So here we can click on community. So if our main goal is to work on core Python itself, then we can download the community version, which is available for free. We don't have to pay any licensing fees here. And if we want to work with the professional, for example, if we want to work with other language integrations as well, then we can go ahead and download the professional version. So for our hands-on, we can use the community version. For getting started, it won't be of any issue. And once we install PyCharm, for example, to open a PyCharm, so here we can search for PyCharm. And here, once we have the community version installed, we can open up this version, and this is going to be open up in the browser, through which we can get started working on it. So let me showcase you how exactly it looks like. So if you want, we can start by working on any project, or if you want to start working on a new project, then we can work on a new project as well. So for example, let's say we want to work on a new project. So here we can click on file, and here we have new project. We can choose the interpreter. For example, we have installed multiple versions of Python, then we can choose which version we want to work with. And then we can define currently we are working on Python 3.8. If we have multiple interpreter defined, for example, we are using Python 2.7, 3.9, 3.6. So if we have multiple versions configured, then we can choose the correct version accordingly. And to work with Python, for example, let's say we are working with the Python, right? So let's say we remove this current code. So let's say we are working with Python. So this is the PyCharm, then this is the default ID that we have. So we can see the entire folder structure. Here we can start typing the entire code. And then if you want to work on any file here, we can right click on the file. Here we can click on new, and then we can click on the type of file. For example, we are going to create a file by the name of demo.py. So here we have demo.py, and to get started, we can simply define the Python code. For example, we want to perform a simple operation as x is equal to 9, y is equal to 7, and now we want to print the sum of these two. So you can define print x plus y, and then if we want to run this, we can click on run demo, and the same code is going to be executed within the ID, and then we can see the result being shown to us. So that's how we can work with PyCharm. Next, let's discuss on the concept for overview for machine learning. So machine learning is basically a type of AI that allows software application to learn from the data and become more accurate in predicting outcomes without human intervention. So it seemed like training any kid, or even now, how exactly we know how to type? Because someone has taught us. How exactly we know how to speak? Because someone has taught us, right? So when we want any human to perform something, for example, we train the kids, we train children to how to walk, how to talk, how to write, how to do everything, correct? And we show them, we train them by, again, with examples, or we let them learn on their own. There are multiple methods, correct? Now, if we are not training someone, so obviously they are not going to learn, correct? Because even though someone is smart, but again, they have to be trained to in order to make sure that they are using their entire computational power in the right direction and create something good out of it. And that exactly is what machine learning is all about. So let's say when we are building a system, let's say when we are building a system or tool that can detect the, suppose we are building a system that can detect if there are any flowers in the given image. So if we want that this system should work, we have to make sure that the system should be able to detect any flowers in the given system, correct? So if we have two different systems with us, let's say we have system A, and then on the other hand, we have system B. So system A has been trained by using, suppose, 1,000 images, has been trained by using 1,000 images, whereas system B has been trained by using 10,000 images. So which one is going to have a higher accuracy? If system A has been trained by 1,000 images and system B has been trained with 10,000 images, so which one of them is going to have a better accuracy? Absolutely system B, correct? Because system A, although the system A may have a slightly better algorithm, but again, system B has been trained with more variations, more amount of data, and that's why we have to first of all to automate the entire process to increase the accuracy with which the model can detect something. We have to work on ingesting as much data as possible. And that's the main reason why Google has been undisputed king since almost 2 decades now. So any idea why Google is king? Why no one has been able to beat Google? It's almost 2 decades now. Now there are multiple other companies, like we have Apple, we have Microsoft. Again, they are not short in terms of resources, correct? Even they have more resources than Google has. But what's one thing that no one else has the access to? That user data. So Google has almost data for every user available on the planet, correct? If you are going to ask for navigation, we have to use Google Maps. If we want to search something, we have to use Google search. If we are looking to send emails, majority of the audience, they send emails by using Gmail, correct? If we are looking to if you're using our phones, then almost 80% of the all the smartphones globally, they all are powered by Android, right? That means every activity, our entire digital footprint again is tracked by Google. And that's why Google has such enormous amount of data, of user data, for every user who is active over the internet. And that's why Google has been able to efficiently harvest this data and derive information out of it, so that, and using this information only, it is continuously improvising its each and every product. And that's why no other company has been able to beat Google, because they simply may have more resources, but one thing they cannot have, and they don't have as of now, is the user data, right? So, and that's why machine learning as is an integral component when we are talking about the machine learning concepts. So if we talk about machine learning, then there are three types of learning available. We have supervised, unsupervised, and then we have reinforcement learning. Now, to understand these types in simple layman terms, we can understand this by talking about examples. So first of all, supervised learning is where we have the input variable as X and output variable Y, and we use an algorithm to learn the mapping function from the input to the output. So in simple layman terms, we can understand this by taking the example for emails. So if we talk about emails, let's go to our annotation mode. So when we are using our Gmail, so you must have seen that in Gmail, emails are automatically sorted. Emails are automatically sorted. So whenever any email comes to our inbox, so again, Gmail automatically detect Gmail automatically detects, okay, which particular, now this particular mail is going to be sorted in which category. This one should be going to the primary inbox. This one should be going to the promotional, like primary, promotional, or this one should be going to the social email address or social email box, or one should be going to the spam. So it automatically segregates that this email belongs to which particular category, primary, promo, or social. And kindly excuse for this beautiful calligraphy. That's what happens when you try to write using the mouse pointers. Any idea on how these emails are being sorted? So basically here what we have here, here it's a simple example for supervised where we use labeled data set. So for example, let's say whenever any email comes to Gmail, so if that email contains multiple images, then again it's a recipe for what? It's a recipe for promotional email, because normal email will not have these many images, correct? If the email contains words such as offers, discount, buy now, shop now, again they are recipe for the promotional. If the email contains, suppose if the email is from different providers, suppose email is from Facebook, Twitter, Instagram, they are a good recipe for the social emails. If the emails are about winning, we can say winning a lottery, or doing some bank deposits, or if the emails are from spam servers, so again they are recipes for the spam content. And if the email is from known contacts, if the email contains suppose invoices or notices or from unknown contacts, then they are a recipe from the primary inbox. So there are multiple labels available in the email that has been used for segregating email in different email types, whether it is going to be primary, promotional, social, spam. And when we sort something, when we train the data by using these labeled data set, when you train any particular model by using these labeled data set, then this is referred as supervised learning. A simple example of how the sorting for different emails happen. All right, so after supervised, we have something called as unsupervised learning. So in supervised, we have seen that we use labeled data set. In supervised, we use labeled data set. And when we are working with unsupervised, we don't use any kind of labeled data set. So let's understand the same concept of unsupervised by using another simple example. So we had discussed there are multiple models are also available under machine learning that we can refer to. So basically we have supervised, we have unsupervised, we have reinforcement, and again in here there are multiple types of machine learning models that we can work on. So like we have linear regression, we have classification, we have random forest, we have NumPys, we have logistic regression, decision trees. So these all are examples for the supervised learning models. And again, these all are different algorithms. These all are models that we can make use of when we are working with any data set. So let's understand the concept of unsupervised learning first before we see the actual algorithm. So unsupervised learning is basically training the model by using information that is neither classified or labeled. So if we don't have any kind of labeled data set like we have seen in the example for mails, so if we don't have any kind of mailing data set, then we can use the unsupervised learning model. So to see a small hands-on, we can take the help of the media streaming services. For example, we can come back to our annotation mode. Now, when we are watching YouTube, we all must be using YouTube and Netflix, right? We all must be using YouTube or Netflix. So when you're watching any video, suppose we are watching something over Netflix. Now suppose there's a user. Now this user is trying to watch something, suppose on Netflix. Now this user opened up 3 different movies. Suppose the first movie in the genre for comedy. Suppose this user opened up the genre for comedy. And under comedy, this user try to watch 3 movies. The first movie, movie A. This user watched this movie A, suppose for 2 minutes, 2 seconds. The user watched movie B for, let's say, 1 minute 38 seconds, and same user watched movie C. Now all are in the same genre as comedy, and this movie was watched for, suppose, let's say, just 3 minutes. Just 3 minutes. All right. Now the user switched the genre to, suppose, to horror. Switch the genre to, suppose, horror. So now in under horror, the user watched only just one movie, and the user watched the movie, suppose, for 1 hour 48 minutes. 1 hour 48 minutes. So if the user watched the entire movie for 1 hour and 48 minutes, suppose for complete 1 hour, 1 minute and 48 seconds. So again, the user is going to be recommended more movies in under comedy or more movies under horror based on this user history. So the user is going to be recommended more of comedy movies or more of horror movies. The user is going to get more recommendations on the horror movie types. Why? Although the user has tried to watch more number of movies in terms of comedy, but the actual watch time has been less for these movies, correct? Whereas the user has watched just one movie, but again, then the user has watched a complete movie. That's why user is more interested in watching this kind of movie, and that is going to be, and that's going to have more weightage as compared to multiple movies the user may have opened up under comedy genre. So that's why we have to make sure that, okay, again, this is not a specific label type, right? So this is what a simple example for unsupervised learning is. This is what a simple unsupervised learning is. All right. And that exactly is what we have as a part of unsupervised learning when we are using the unlabeled data set. And in the unlabeled data set category, we have multiple other algorithms used here. Like we have the k-means, we have the hierarchical clustering. Again, these all algorithms are being used under unsupervised that we are going to talk about. And then we have reinforcement learning. So reinforcement learning is basically training the system by using some reference point, or we can say by training the system by using some reference point. As in, let's suppose we are building a system that should automatically give a positive feedback to the system when the system does something right, and if the system performs not well, then it should be penalized as well. For example, we have the self-driven cars. So the car hits a roadblock, again, that is going to attract negative points for the car system. So the car will know, okay, if the car has done something wrong, and then it will try to improvise its entire functioning again. And that's why suppose if the results are good, then the system will be rewarded, so that the system knows, okay, the system has done something good, so that it can try to make sure the same steps are also being repeated to improvise the process. All right. And that exactly is what reinforcement learning is all about. So we can take this of a famous example for Pavlov. So we have a Pavlov model. So if you talk about Pavlov model, let's discuss what exactly it is. To understand that in simple layman terms, we can refer to one diagram so that we can have a complete clarity of how this model has been treated. All right, so here we can refer to this particular diagram here for Pavlov. Now, mammals, they have a habit of starting levitating. Again, the mammals simply start salivating the moment they see their favorite food. Okay, it's not it's a natural behavior for mammals. Even humans, we also do that. Once we order something in our favorite restaurant, and when we see our food coming in, we start salivating. That's a natural human behavior. And let's say if the dog sees their food, they are going to start salivating. That's a natural behavior, being a mammal. And now, if we want that dogs should start salivating the moment they hear a bell ring, then this is not going to happen naturally, because dogs are not built to start salivating the moment they hear a ring bell, because they know they cannot eat bell, and bell is not a food that they would like to eat, correct? That's why it is not going to be a natural stimulus, a natural response. So how we can train the dog to start salivating the moment they hear the bell ring? So after ringing the bell, we start bringing the food. So as the bell rings, the dog will get the food, and after 1 week of doing the same activity, that means ringing a bell first and then bringing in the food, So now dog will recognize, it will learn that when a bell rings, that means the food is on its way, right? And then suppose after 1 week, the moment we start ringing the bell, the dog is going to start celebrating automatically because now dog has been trained to expect the food coming in after the bell rings. And that's how we can train any system based on giving the feedback. If something goes good or something goes bad, then that's exactly how we can train the system as a part of reinforcement learning. And a good example is, let's say we have the entire self-driven cars. We have the automatic image detection models that we have, correct? And this exactly is what we have as a part of reinforcement learning. All right. So these all are different learning models that we can make use of. And there are multiple algorithms as well. For example, let's say we want to work with any algorithm. For example, suppose we have logistic regression, we have linear regression, we have the decision tree, naive we have multiple use cases on which we can work on to find the possibility, to find the probability for anything that we can make use of these different algorithms. So earlier have been working on workshops as well, focused on finishing placement prediction on one of the world's most famous game, that is PUBG. So let me give you a quick glimpse on how data science helped us in in finding out the answers to certain questions as a part of data science analyst. So currently we are working on Colab. So Colab is basically just like we have Jupyter, we also have Colab as a notebook that we can work with. So currently, earlier in our earlier workshops, we had worked on finding multiple answers to the questions for on this particular game. For example, we have performed EDA on multiple pointers of the game. For example, we want to find out if killing more number of players has a positive impact on winning place percentage or not. So we can test this hypothesis by using the prediction by performing the entire EDA on the data that we have. We can find what is the relation between the number of heals and number of boost items taken up by the players and what impact it has on the winning place percentage. So again, they along with creation of a model that is going to predict the chances of a player winning the game given based on the current parameters. So these all predictions we had discussed in detail as a part of the workshop. And to give you a quick glimpse of how the EDA concept is done, we can first of all work on importing multiple libraries as well. So for the analysis part, we can import NumPy, Pandas, Matplotlib, Cpon, and iteration tools. So NumPy we use for the calculation, Pandas we use for working with data frames, and then we use Matplotlib. All right. And here we can import NumPy for the calculations, Pandas for working with data frames, and where we can store the entire access to data. So we had the access to data based on the now this data for the analysis was made available by PUBG itself. So they have made the game statistics for more than 65,000 matches public for anyone to start analyzing on top of it. And then we have used matplotlib and cpon for the visualization part, and then iterations to simply repeat the task based on the given pointers and semi for warnings. So once we load the data, for example, we have multiple data pointers in a given data set. For example, we have kill plays, we have the match ID, we have the group ID. Match ID refers to the match ID for different matches that are for which we have the access to data. ID simply refers to the user, or we can say player ID. Then we have the assist, then we have the damage dealt, then we have the knockouts. We have data for headshot kills, for the number of heal items used. We have data for the kill plays, the longest kill, the kill streaks, how many revives, the right distance. That means these all are different data pointers available in the official data set. So we have to go to the same section for settings. And if we are using PyCharm, then we can go to the project interpreter and then we can install these libraries. So these libraries can be installed by the GUI itself when we are using PyCharm, or we can download the libraries that we are going to work on. So and then once we have the libraries downloaded, then we have to import these libraries as a part of the project. Then only we can start using these libraries in the given project. All right. Now, suppose we want to find the relation, right? We want to find the correlation between different data pointers. For example, let's say we want to analyze the kills. That means or we want to find the correlation between multiple data pointers. For example, let's say we want to analyze running. What exactly the impact of running is on the winning place percentage. So here we can analyze running. So basically, by using the analysis here, first of all, we can find out the average we can say the average distance any single person runs. What is the average distance a person runs? And then we can plot the same graph for winning place percentage as well. For example, let's say we want to plot the graph here. So here we can make use of a joint plot graph where we can use the SNS library, SNS as in Seaborn, and then on the x-axis we can place the winning place percentage, and on y-axis we can place the walking distance, and then we can define the appearance of the entire graph, and then we can see the entire analysis has been done. So the walking distance, as you can see here, as a part of this graph, we can see as soon as the walking distance increases, the winning place percentage also increases. So when we now currently we are checking the correlation of winning place percentage with the walk distance. That means if a correlation is closer to zero, that means they are not correlated at all. And if the correlation is closer to 1, that means they are highly correlated. So you can see as the walking distance increases, so does the winning place percentage as well. And that's why we can see they both are highly correlated. That means if a player is able to walk more distance, is able to have more walking distance in the game, then the person is having a good chance of winning the game as well. Same way we can perform the EDA on driving as well. For example, let's say we want to find out at an average, a person drives for how many meters, and 99% of players they have driven for how many meters, and while the rider, that means per player having the longest drive record, again, how much distance that player has ridden. So for finding this, we can simply make use of the train data frame that we have used. And then for finding the average, we are going to use mean from the ride distance data pointer available in the data set. For finding the 99%, what is the data record for 99% of users? So there we can make use of 99 quartile, just like we have box plot. And then for finding the maximum value, we can find maximum value from the ride distance from the train data frame that we have imported. So you can see here an average person rides for almost 606 meters, whereas 99% of people have driven for almost 6,966 meters. That is close to 7 kilometers. While the rider, that means a player having you can say the best record for ride distance, that player has ridden for almost 40 kilometers in a given game. And same way we can perform the analysis of the winning place percentage for the walk distance for the ride distance as well. Again, we can see we have plotted the same graph on x-axis and y-axis, and we can see as soon as the ride distance increases, so does the chance of winning the game as well. The winning correlation also changes, and that means if a player is able to have more number of, we can say, travel more, then the player is going to have a positive impact on winning the game as well. Same way we can analyze the boosting and healing effect by performing this kind of EDA. So first of all, we are going to plot that graph for the people who are using, or like how much number of heal items the player uses. That means 99% of players uses how many heal items, and same way 99% of people uses how many boost items. And then by using the SNS as in the Seaborn library, we are going to work on a point cloud graph where on x-axis, now we are in the same graph, we are going to plot two graphs here, one for the heals and one for the boost. So on x-axis, we have defined number of heals and the winning place percentage on y-axis, whereas for the other graph we have used on x-axis, we have plotted the number of boost items, and the on a y we have a common winning place percentage by giving different colors. And then we can define each and every labels, how exactly we want to display the graph. And based on the current analysis, we can see both the heals and both the boost, again, they both have a positive impact. both of these items, they have a positive impact on the winning place percentage. But as you can see here, beyond a certain point, that means beyond 2 heels, the impact of heels on winning place percentage is not higher as compared to the number of boost items. So if the player is able to get more number of boost items, then the winning place percentage, the correlation goes to as high as 0.9. Whereas for the number of heels, it remains static to around 0.7 itself. So it's a simple glimpse of how exactly the EDA happens. When we say EDA, it simply means exploratory data analysis, how the EDA happens for different sets of data that we have the access to. That's how EDA is structured. EDA refers to exploratory data analysis. So basically here we perform multiple techniques. So we can use point block, we can use box plot, the point plot graphs, the histograms, the bar chart to simply define plot multiple data pointers based on the logic. And that's how we analyze and we check our own hypothesis. Thank you so much for joining and have a great day ahead. Take care. Bye-bye.